Hello, children. Wish you all a very good health. I had sent you the notes of nitric acid. Now, the explanation. This will help you to understand the chapter better. Nitric acid is called aqua fortis, meaning strong water, due to its corrosive action on almost all metals, even silver. Here, remember, aqua fortis. The chemical compound in aqua fortis is nitric acid. Lab preparation of nitric acid. The reactants are sodium nitrate or potassium nitrate and concentrated sulfuric acid. Here, concentrated sulfuric acid acts as a non-volatile acid, capable of displacing the more volatile acid from the latter's salt. KNO3 plus H2SO4 less than 200 degrees Celsius gives me KHSO4 plus HNO3. 2KNO3 plus H2SO4 temperature greater than 200 degrees Celsius gives me K2SO4 plus 2HNO3. Remember your symbols and valencies well, children. Here, K plus HSO4 minus gives me KHSO4 potassium hydrogen sulfate or potassium bisulfate. K plus and SO4 minus 2 gives me K2SO4 potassium sulfate. Color of pure nitric acid. Colorless. But in the lab it takes a yellowish brown color. Why? Because a part of nitric acid decomposes to give nitrogen dioxide. Remember, decomposes to give nitrogen dioxide, which remains dissolved in the acid, imparting yellowish brown color. Removal of yellow color by passing dry air or CO2, by diluting it with water. Why temperatures above 200 degrees Celsius is not used? Because the glass apparatus may crack. The acid may decompose, fuel is wasted, and sodium sulfate forms a hard crust which sticks to the apparatus and is difficult to remove. Special feature of the apparatus used. An all glass apparatus is used because nitric acid vapors are highly corrosive and they attack rubber, cork, etc. So this was all the lab preparation of nitric acid. You have all the points, children. Learn it well, thoroughly. We come to the industrial preparation of nitric acid. It is termed as Ostwald's process. Catalytic chamber. 4NH3 plus 5O2 catalyst platinum at 800 degrees Celsius gives me 4NO plus 6H2O plus, remember, the triangle stands for heat evolved. The reaction is exothermic in nature. The ratio of ammonia and oxygen used, 1:10 by volume. 1:10 by volume. I repeat it. Why? Higher ratio by volume of air is used because oxygen is used in all the 3 steps of Ostwald's process. Second step, oxidation chamber. 2NO plus O2 at 50 degrees Celsius gives me 2NO2. In the absorption tower, you have 4NO2 plus O2 plus 2H2O giving me 4HNO3. The absorption tower is made of quartz because it is acid resistant. I had asked you children to go through the physical properties of nitric acid, and I know that you must have done that. Next, chemical properties of nitric acid. The most important is the oxidizing nature or property of nitric acid. Carbon plus 4HNO3 giving me CO2 plus 2H2O plus 4NO2. Sulfur with concentrated nitric acid giving me sulfuric acid plus water plus nitrogen dioxide. Now these four equations which I am showing you are very important. Just have a look here. Cu plus 4HNO3, hot, concentrated, gives me copper nitrate plus 2H2O plus 2NO2. Here 3Cu plus 8HNO3, cold, dilute nitric acid gives me copper nitrate, water, but 2NO. So you can see the difference between the gases evolved. So this was all about the chemical properties of nitric acid. I remember giving you homework to solve the back exercise neatly in the textbook. I hope you must have done it. Remember, you should do your work neatly as I have taught you in class, and write your notes very clearly with the arrows, with the points as I have been teaching you. All the best. Stay safe, children. This is the end of the shortest and the sweetest chapter of your book, Nitric Acid.